Okay, so we've seen how vanilla replica sets usually work with a write concern of majority. With that in mind, what could possibly go wrong? Not much, unless we switch out a secondary for an arbiter. Now I've only got one path to get my data acknowledged. This still works, but only as long as nothing goes wrong. If a partition occurs between my primary and secondary, then my primary can't acknowledge any writes until the partition is resolved. Similarly, if that secondary goes down, then my writes won't get acknowledged until that secondary is back up. Keep this in mind. A replica set with an arbiter in place of a data-bearing server is better than an even number of replica set members, but it can also cause bad situations when anything else goes wrong. Let's go back to the situation with 3 data-bearing members, but ask what happens with a delayed secondary. A delayed secondary is only about as good as an arbiter for purposes of ensuring that your W majority writes go through. That's because you need to add your delay to any time for a write to occur and get acknowledged. So if a secondary is delayed by 5 hours, then that secondary won't acknowledge any of the writes for 5 hours, which will be a problem if my theoretically up-to-date secondary goes down. Of course, you're always better off with a larger replica set. So this brings up an interesting point. You should always go through the routine of calculating how many servers you need at minimum for a majority. Remember, this is about write concern, not your ability to elect a primary. Don't count an arbiter, if you have one, since it can't hold data. Don't count delayed secondaries. You want to know how many servers you need to write to before you can get that acknowledged. And you want to know how many of them can be out of the picture, either because they're down or because of network partitions. Then, figure out how robust your system is to your standard servers going down.